and integrate blood. Blood is a connective tissue, you know. It includes two colloid systems. Colloid systems formed elements, mostly erythrocytes, and proteins. The blood composition, plasma, about 55%. It may be more or less, depends on gender, men, women, but about it. And formed elements. Formed elements or blood cells. Formed elements.
Like leukocyte and erythrocytes?
Yes, of course. Formed elements. Formed elements, percentage about 45. 45. See that group consists of includes erythrocytes, leukocytes, and platelets or thrombocytes. So names platelets. Platelets or thrombocytes. Thrombocytes. Значит, now, erythrocytes has huge number. The main component for elements for the elements part. Ratio between formed elements and plasma, about 45, is called hematocrit. Yeah? Hematocrit. Hematocrit. Increase hematocrit means mostly disorder of erythropoiesis. Sometimes it may be a little increase, may be a result of adaptation. For example, when person lives on altitude in mountains and he has hypoxia due to lower facial pressure of oxygen in air, so it's necessary to have adaptation, hypoxia. Yeah. But a person living at mountains and at altitude has adaptation to increase numbers of erythrocytes, more than normal. Decrease of hematocrit means anemia, mostly anemia. As increase erythrocytes more than normal means erythropoiesis, 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 and decrease erythropenia or anemia, mostly anemia.
Anemia form is
Anemia decrease more than normal. Mostly it's result anemia. Erythropoiesis, erythrocytosis, erythropoiesis, synthesis of erythrocytes. Erythrocytosis.
Cytosis mean increase.
Erythrocytosis means increased production. Erythropoiesis,
Formation.
synthesis of erythrocytes. Erythrocytosis, increase of numbers, more than normal. Maybe physiological adaptation, but physiological erythrocytosis increases number of erythrocytes, not more than 6.5 more 6.5 and 10 to 12 power per liter. It's pathological. 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 Less than this number, maybe physiological adaptation. Leukocytes. Leukocytes compound leukocytes number is less than erythrocytes, and platelets between erythrocytes and leukocytes. Plasma components. Plasma components mostly water percentage, water, salts, ions. Main inorganic salt in the blood, sodium chloride, 0.9%. Physiological solution has the same content. Salt and are organic substances. Organic substances. Organic compounds includes nutrients, mostly proteins. Proteins contain about 7-8% of plasma volume. Proteins and other nutrients, amino acid, lipids, lipoproteins, free fatty acids, glucose, some percent. That is biochemistry of blood. Biochemistry exam, blood biochemistry exam estimates mostly organic substances. Proteins. Blood composition. Stable variables of blood are important to provide living processes. But where some variables can be changed to more amount, more number, without problem for these variables are called flexible variables. Flexible. Blood variables, homeostatic variables,
Variables.
Variables, more correct pronunciation. Variables, the physical or chemical parameters of blood. Variables. It's homeostatic term. Variables. Maybe flex. No. Homeostatic. Don't mix with hemostatic. Homeostasis is a steady state of the body. Homeostasis. Hemostasis means blood clotting. Different, huh? Homeostatic.
Homeostatic.
Homeostasis is the steady, relatively steady condition of the body. It means more or less stationary variables. Flexible, for example, numbers of erythrocytes, leukocytes. For example, erythrocytes may be a number normal value between 4 and 5, multiply 10 to the 12th power per liter. But it may be 3.7, 5.5, sometimes 6 in person adapted to mountain, maybe 7. It doesn't disorder living processes. It can move, can shift due to adaptation. Thrombocyte hematocrit, hemoglobin content, hemoglobin content. At first, doctor examines total hemoglobin content. Hemoglobin. Um, Hemoglobin is inside erythrocytes. It can be present freely. Hemoglobin content about 120, 140 milligram per liter in women, and a little more
Milligram or millimeter?
milligram, gram, weight, mass, yeah? In because usually a man has more number of erythrocytes. It's also consequently more hemoglobin. But the doctor examines then concentration of hemoglobin in each erythrocyte by special counting and average concentration of average amount of hemoglobin inside in each erythrocyte. Hemoglobin total amount, MCH, MCHC. It's a laboratory medical test. What more? Glucose concentration. Concentration of glucose depending on units, milligram per milliliter or millimole per liter and different units. Glucose concentration can increase double after eating, and no problem for the body. Much more. Very important, erythrocyte sedimentation rate. Erythrocyte sedimentation rate.
Result.
Right. Concentration. And thrombocytes. This is not normal values. You must know it. Not all numbers of blood variables, but these numbers of erythrocyte, leukocyte, hemoglobin content, total hemoglobin content, erythrocyte sedimentation rate. What is it?
Deposition. To challenge himself.
Erythrocyte sedimentation rate. At first, you take some blood sample, dissolve with anticoagulant, sodium citrate mostly, to prevent clot formation, maintain viscosity, and put capillary with blood sample, vertical position, blood here, per 1 hour. 1 hour. In 1 hour, erythrocyte will be collected lower. Erythrocyte mass, erythrocytes, and upper part is
Plasma?
lighter. Light is just plasma. Plasma without erythrocytes. And length of this light part, length of this column, is called erythrocyte sedimentation rate. It means free plasma without erythrocyte after 1 hour vertical position, blood sample. How erythrocytes are moving to down? Freely or stick together? Stick together.
They stick together.
Because erythrocyte is a nuclear biconcave disc. Biconcave to increase surface of binding oxygen to hemoglobin to provide gas transport function. Erythrocyte is charged outside by negative charge due to special molecules inside erythrocyte membrane. Cell acid, negative charge membrane. Plasma contains different proteins, globulins, and albumins. albumins, smaller molecules, albumins, negatively charged also, albumins, and globulins, another fraction. Globulins, bigger molecules, protein molecules, charged by positively. So globulins form electrostatic attraction between adjacent erythrocytes and stick erythrocyte each to other. So the more globulins in the blood, more erythrocyte sedimentation rate. It happens faster. What is a normal value for erythrocyte sedimentation rate? In men, between 1 and 10 millimeter per hour, 1 hour. In men, in women, between 2 and 50, a little more. Because women's body contains special hormones. Some of these hormones are included to globulin fraction.
Like project.
Pregnant women can have normally more. For example, 30 pregnant women. It's not pregnant, healthy, not pregnant.
In the infection, increase of the infection.
Infection, yes. This is normal. Normal men and not pregnant women. During immune response to reinfection or autoimmune disease, maybe tumor, cancer, immune system releases a lot of globulins. For example, antibody immune globulins. They are included to globulin fraction. So, erythrocyte sedimentation rate rises too much. Another factor may be anemia. Less erythrocytes and faster erythrocyte sedimentation rate. Another factor, influencing factor, blood viscosity. But mostly a shift of erythrocyte sedimentation rate is due to infectious disease. The rest of cases are rarely special. It's necessary to know the details. For you, analysis, erythrocyte sedimentation rate, glucose, and chemical. It's enough flexible. Another type of variables are rigid. Rigid means that this variable must be stable, stationary, more stationary, and it can shift to maybe little percent, for example 0.1% from the normal flexion, from the normal level. What are the rigid variables? pH. Normal pH in arterial blood must be 7.2. Remember, pH. Osmotic pressure about 7.4 atmosphere or 5,700 milliosmoles. No, millimeter Hg. Or another variable reflecting medical test, variable reflecting osmotic pressure, osmolarity, about 300 milliosmoles. Osmotic pressure and osmolarity both reflect content of osmotic active substances. Sodium chloride, mostly glucose is osmotic active substances, and others, but mostly at first sodium chloride, and secondly glucose.
Make viscosity, yes?
No, osmolarity.
Osmolarity.
Viscosity depends on erythrocytes and proteins and hemoglobin. Ratio between erythrocyte numbers and plasma. Osmolarity reflects content of salts and glucose. Sodium chloride and glucose are main compound, making osmolarity. About 300. More correct numbers 297, but it's difficult to remember 300. Значит, next, osmolarity, pH, sodium chloride content. Sodium chloride, I said before, 0.9% physiological solution. Why? For example, take water without salts, pure water, still water, glass with water, pure water, without salt. If you put sample blood, several drops inside pure water, what happens with the erythrocyte? Erythrocyte contains salt. Osmotic pressure inside erythrocyte more than in water. It attracts water.
It will be pumped.
Osmotic gradient. It has osmotic gradient. A membrane of erythrocyte contains aquaporins, water channels, and water goes inside erythrocyte. Erythrocyte swelling and break. Arrange to start breaking erythrocyte about 0.5 sodium chloride concentration. It breaks about 50% of erythrocyte and about 3% total breaking. Deadline. Total breaking erythrocyte, not erythrocyte. It's 50% damage. 50% damage. It's test osmotic resistance. Resistance of erythrocyte. But I explain just this principle. This effect is called hemolysis. Osmotic hemolysis. Osmotic hemolysis. Hemolysis may be not only osmotic, may be mechanical or immune hemolysis. For example, after transfusion of incompatible blood group. I will explain later about this. Okay. Osmolarity, sodium chloride, protein content. Protein content also here. Proteins, because proteins provide viscosity. Proteins, 7-8%. Proteins and oxygen, carbon dioxide amount, content, oxygen, carbon dioxide. Numbers you can see in my presentation. I think it's enough. I forgot. And oncotic pressure. Oncotic pressure or colloid pressure, it's a part of osmotic pressure, but separated part. Oncotic pressure must be 25-30 millimeter Hg, much less compared with total osmotic pressure, but colloid pressure of blood is crucial to provide filtration and absorption. I explained it during last class. for group 1. And I'll explain for group 2 tomorrow. Значит, calorie pressure. It's enough. Because you must know these variables. They are presented in my presentation. And to know numbers. About functions, blood quant elements, functions. Very important. What are the main functions of erythrocytes?
Transport oxygen.
Oxygen and carbon dioxide. Yes. But it's not a single function. Erythrocyte can transport some lipids and hormones absorbed on their surface. Transport function. Another function, buffer function. Buffer function. They have participants in pH maintenance. Erythrocytes. Erythrocyte by concave. It's natural erythrocytes. But sometimes the blood contains a little to about 1 to 2% precursor of adult natural erythrocytes. Erythrocytes transport oxygen, carbon dioxide. We will study it next topic, respiratory system, about biochemical reactions, hemoglobin with oxygen, oxyhemoglobin, and carbon dioxide. Carboaminohemoglobin. And the erythrocytes converts carbon dioxide to bicarbonates. And bicarbonates goes to plasma. First function, transport. Second function, buffer function. Buffer function, maintain pH. Due to bicarbonates and hemoglobin system. Hemoglobin and bicarbonates. Conversion of bicarbonates. It's about erythrocytes. Leukocytes. Leukocytes is a group, big group of formed elements containing 5 types. 5 types of the leukocytes. Granulocytes, agranulocytes. You studied it in histology, of course. Granulocytes, neutrophils.
Eosinophils
Eosinophils.
and basophils.
Basophils. Granulocytes. Next group, agranulocytes.
Lymphocyte and monocytes.
Monocytes and lymphocytes. You must know shortly function of each type. All leukocytes provide defense or protection functions. Defense, protection. Against invaders, infections, virus, bacteria, cell, tumor cells, cancer cell, protection. What does a neutrophil do? Phagocytosis. To kill cells, invader cells, by phagocytosis. Neutrophils moves to invader due to chemotaxis. Surrounds invader. Surrounds invader and eat. Digest fully, destroy, full destruction. It's innate immunity. Inherited, innate immunity. Eosinophils are capable to for phagocytosis also, but eosinophil works mostly to eat products of immune responses and provides antitoxic function. Antitoxin after immune response or during immune response with absorption and inactivation of immune active substances like histamine. Antitoxic, first function, antitoxic, absorption of histamine, uh, complexes, antigen, antibody, and others. Eosinophil contain enzyme histaminase. If person has normal content of each leukocytes except eosinophil and numbers of eosinophil is increased, maybe it means a response to allergen. And second function of eosinophils to kill parasites. Anti-worm, anti-virus. By releasing special killing substances outside. Phagocytosis destroys molecules of invader inside and killing parasites outside. Basophils. Basophils granules contain histamine, release histamine and heparin. Histamine and heparin to provide local immune response. Histamine dilates blood vessels to increase blood circulation in damaged region, and heparin decreases coagulation, prevents coagulation. It makes blood more fluid, decreases viscosity.
Mhm.
So both effects increase blood circulation in the damaged area. Okay. Monocytes. Monocytes, at first, monocytes are capable for phagocytosis like neutrophils, but monocytes, after eating invader, present antigen on the surface. It's called antigen present response. Antigen may be polysaccharide or protein molecule or part of protein molecule, sometimes nucleic acid, DNA, RNA, mostly proteins. And this composition, antigen binding to a surface of monocyte surface, starts activation of lymphocytes. It activates some type of lymphocytes. Lymphocytes may be divided to principal three groups. Did you study groups lymphocytes?
No,
Okay.
T down CDB,
T,
T,
B,
and
Amora,
killer,
natural killers. Natural killers. T, B, and natural killers. This is not. Again, I will write here lymphocytes. C, B, and natural killers. We don't have a class about immune system, unfortunately, because it's very important for medicine. So I have just time to explain it. Very important for your life. What is the difference between TB and natural killers? Natural killers provide innate immunity, not specific immunity. Non-specific. What does it mean? Non-specific immunity. Like neutrophils.
Damage everything. Damage everything.
Yes.
Affect everything.
Protect against every environment, independently of antigen. But response of defense response of natural killer differs from phagocytosis. Natural killers are especially important for tumor cells. Natural killers connect with invader or tumor cells. Each cell contains marker histocompatibility complex. Histocompatibility complex, MHC, do you know? Major histocompatibility compatibility complex. Do you
No.
study?
No.
تو ایمونولوژی داریم چه
Strange. Maybe microbiology, immune system. Major histocompatibility complex. Most of the most cells contain first type MHC1, except antigen presenting cells and most MHC2, MHC1, and for cell natural killer has contact with MHC1 to detect cell and another receptor, natural killer, contact with another cell. Some receptor have inhibitory influence. Some receptor has stimulatory influence. Inhibitory, here stimulatory. Stimulatory influence and balance between inhibitory connection and stimulatory connection defines the response of natural killer. And here you can see everything okay, mostly inhibitory.
Mhm.
Another situation, another cells. With, for example, is that our cells became tumor cells. It produces a lot of antigen, and situation has changed with prevalence of stimulatory influence. Natural killer recognized again. Two inhibitory connection and free stimulatory. So mentioned more stimulation. In this case, natural killer releases substances, protein, special protein, forming pore channel. This protein is called perforin. And cytoplasm bad cell is flows out and cell dies. It's what is the name of this response? Did you study such response?
Not specific.
No specific name of it. Cytotoxic. Do you know? Cytotoxic
Yes.
response. Cytotoxic. So our immune system has two principal response to destroy bad cells: phagocytosis, and cytotoxic response. Cytotoxic reaction. Mechanism. Phagocytosis destroys inside immune cells. Cytotoxic reaction outside.
Inside.
Outside. Immune cells outside, around. Um, but what about T and B? T and B lymphocyte provides specific immunity. Specific immunity. T cells.
Immune
grow-
mediated. Immune mediated.
Regulatory
T
cells. Yeah? Значит,
Immune.
T cells may be T helper, T killer, and T suppressor. T suppressor. Actually, these cells have a new, more appropriate scientific name, but you can use this. T helper. T helper contains special marker CD4 plus. Did you study it? Markers. Killer CD8 plus. It's not important for you to remember, but it's a modern scientific marker of the cells. T helper. T helper recognized monocytes connected with antigen, presented antigen, and after connection between T helper and this antigen presenting cells, monocytes or dendritic cells, dendrite cells, monocyte releases substance activating T helper. Then active T helpers activates T killers and B cells. This function of T helper is activation of other cells for specific immunity. T killer and B cells. T suppressor has opposite influence. T suppressor inhibits T helper, limits reaction of T helper and T killers. It's a negative feedback because immunity must have a limitation. Immune response is developing with positive feedback, increases. It's necessary to control it because excess of immune response can exhaust immunity and makes weaker to the next invader, or maybe excess of activity may provoke autoimmune response. So it's necessary to have negative feedback. What is the function of B lymphocytes? B lymphocytes produces antibody immunoglobulins. Different types of immunoglobulins. Antibody. What is the function of antibodies? Antibody is a molecule with two talent. There are 5 types of antibody. The antibody can binds to antigen, and antigen loses its activity. It can't work. Antigen. The antigen, for example, is a virus's protein. After this binding, this protein cannot work. So it becomes not active. Neutralization. The first function of antigen. Second function is attraction of other components in immune response, including innate response. It attracts and increases immune responses like phagocytosis, neutrophils, for example, phagocytosis, phagocytes, increase phagocytes, increase activation of complement system. Do you know this? Complement system. Do you know about it?
No.
Complement system is this system of 9 proteins in our plasma. At the beginning, they are not active, and they are activated one by one. This chain of reactions in response to invader entity. There are three waves of activation. One of these wave antibodies. Complement system from C1 factor until C7. Until C7, C6, C7 forms perforin, like natural killer. And cell is destroyed. Perforin. That blood topic has a lot of names of chemical compounds. Perforin. The complement system, very important part. During activation of first complement C1, C2, C1, C3, C5, then this, it has site molecules C3A and C5A. What does it mean? Activation. Some factor, inactive factor, precursor. Inactive factor is a common principle. Inactive factor, for example, C1. Activating factor, another activating factor, breaks this molecule to two parts. One inactive part doesn't work, and second becomes active. This is common principle of activation of any, a lot of proteins. For example, factors of complement system, factors of protein. This factor, A and B. B makes the next step. A is side product, but A is not waste. C3A, C5A increase immune response, like humoral substances, humoral active substances, chemotaxis. They can make anaphylactic shock. Anaphylactic shock. So strong
It's
a
very
strong immune response, higher grade immune response can produce a lot of the factors, can provoke anaphylactic shock.
It's very dangerous.
Very dangerous, especially it might be due to allergy, unexpected excess of allergic response in children. Sometimes it happens in elder person unexpectedly, suddenly. So it's dangerous. And also during transfusion of incompatible blood. Well, so function. Remember function of each cell, shortly. Neutrophils, innate immunity, phagocytosis, first line of defense. Eosinophils, phagocytosis of immune products like histamine and antiparasitic.
Excuse me. How decrease anaphylactic shock with adrenaline?
Epinephrine. Epinephrine increases metabolism. Metabolism and it's higher speed of inactivation. Blood circulation. Yes, you are right. Epinephrine, one of them, and it's a second antihistamine, anti-allergic. B, basophils. Basophils produce histamine, heparin. Resident cell like B cells, mast cells, similar cell, but in tissue, sitting in tissue. Here circulating cells. Monocytes, are capable to for phagocytosis like neutrophil, but monocyte has another function, antigen presenting function, to stimulate specific immunity. And monocytes can migrate to tissues, sit there for a longer time, and convert to microphage. This microphage is resident monocyte. The same. Lymphocytes group, three type of cell, TB, natural killer. Natural killer provides non-specific immunity with cytotoxic reaction. Specific immunity, T and B. T helper, amplifier, stimulate T killer and beta cells. T killer destroy invader again with cytotoxic reaction. T killer kills the cytotoxic reaction, and T suppressor, negative feedback. B cells produce immune globulins, humoral immunity. So cellular immunity, cell immunity, leukocytes, humoral immunity, antibody, complement system, and some antibacterial substances like lysosine, interferons, hormones of immune system. Leukocytic formula. What does it mean? Leukocytic formula is percent ratio between 5 type of leukocyte. You must know it. Neutrophils range between 48 until 72. Total amount of neutrophils. Some textbook, some department can give a little different range, a little more, less, but about it. Eosinophils, 0.5 until 5%. Basophils, 1, from 0 to 1, it's a little. Monocytes, between different maybe values, between 2 9%, and lymphocyte, total amount of lymphocyte between 20 and 40%. You must know this numbers. I will ask you. Neutrophils 48-72 range, eosinophil 0.55, basophil 0.9, monocyte 2.9, 0.1, so sorry, 0.1, monocyte 2.9, and lymphocyte 20-40. Between this. This is percentage of different types of lymphocyte. Why is it important to examine medicine? Because, for example, problem problem with leukopoiesis. Leukopoiesis is production of leukocyte. Leukopoiesis is controlled, regulated by several hormones, hormones of immune system. And all leukocytes except lymphocytes are produced from the one cells, stem cells. Lymphocytes also are produced from stem cells, but has separated pathway. Did you study production of leukocytes in histology? Stem cells.
Yes,
Stem
we studied.
cells,
Yes.
Because the lymphocyte has separated pathways. These pathways controlled by separated hormones. So, for example, you have normal concentration, normal numbers of leukocytes, total numbers of leukocytes, but inside this group, a patient has more lymphocyte, the rest of okay. It means problem with lymphocytes formation. You can give the diagnosis on this base. With leukocytic formula, it's important to give more correct diagnosis. What happens now with immune system? Platelets are important to provide hemostasis. Yeah. Next topic will be about hemostasis because I don't have a lot of time now. You can later see my video, watch my video, and look at the presentation. But I will explain more the rest part of the lecture. I'm going to explain about hemostasis. I will check presence, your presence. One of protective system, defense system. One system, immunity, immune system. Next, hemostasis. But hemostasis is opposed by anti-clotting system.
Anticoagulant.
Very important to have balance between clotting and anti-clotting factors. So blood is liquid, fluid. Blood must flow. Blood must be fluid and blood flows along blood vessels. After damage, vessel damage, normal, here damage side, break. After damage, it's necessary to stop bleeding. Don't lose blood until it aside. It's necessary to stop bleeding. It happens in two stages. At
Was a
first,
constriction?
constriction of blood vessel, of course. At first, I explained bigger stages and details. First stage, platelets are concentrated here and form plaque. Plaque consists of platelets only platelets. Later, if it's not enough, it's enough in smaller blood vessel, for example, capillaries and finger, after cutting. It's enough for not big cutting, little, big by middle. But it's not enough in large blood vessel because the blood pressure is high, and it can remove this plaque. Plaque is not very rigid structure. It requires fibrin. Plaque with fibrin. Fibrin is called clot. Clot is bigger. Clot rises during hemostasis, during clotting. Clot rises. It closes damaged site. Clot rises. But if clot will rise more and more, it's possible to have thrombosis. It's necessary to prevent growth of a clot more than necessary. So immediately after start clotting, anti-clotting mechanism, anticoagulant start to work. Fibrinolysis. Fibrinolysis is damage of fibrin, destruction of fibrin to prevent thrombosis.
Plasminogen? Plasmin?
Plasmin, yes, plasmin. Fibrinolysis is fibrinolysis is response of fibrin destruction by enzyme plasmin. Plasmin is converted from plasmin. Yes, that's correct. So blood must flow freely along normal blood vessel, and in the same time, blood must be capable to make clot. At first plaque and then clot. It's called hemostasis. 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 Blood clotting. Hemostasis has two stage, vascular platelet hemostasis, first stage, vascular platelet hemostasis, and second phase, coagulation or clotting. Coagulation or clotting. Two stages. And last stage, fibrinolysis. And third, fibrinolysis. On each stage, anticoagulants, anti-clotting mechanism,
Heparin.
heparin,
Warfarin.
protein C, yes, okay. Anticoagulants, anti-clotting mechanism, anti-clotting factors, inhibits, have inhibitory influence on clot formation. Every moment our body has balance between clotting mechanism and anti-clotting. How to estimate this balance in a patient? At first, calculate ratio between main substance providing coagulation, clotting, the most important factor,
Fibrinolysis.
thrombin. Fibrinogen is converted by thrombin. Without thrombin, fibrinogen is not dangerous. Thrombin and fibrinolysis factor, plasma. And ratio between thrombin and plasmin must be about 1. Equal, more or less equal. It means good balance. I will check the presence and Ahmad, Amiri, absent. Сидит. Brain work. Good brain work.
أستغفر الله.
Details about hemostatic processes. At first, what factors are recruited to hemostasis? Clotting system, coagulation system includes hemostatic uses platelet or thrombocytes. Platelet. What is the function of platelet in hemostasis? At first, structure, plug and clot, mechanical function, structure. And release factors, platelet factors. Their chemical substances marked numbers, Arabic numbers, from 1 to 12. Arabic numbers, very important. Factors. Next part, plasma. Plasma contain another type of factors, plasma factors, marked classical plasma factors, marked by Raynaud's numbers from first until 13 and two additional factors. This and 15. Finally 15. But first 13 classical with special names. Do you need to know names as factors? I don't require it. Only several names. First, for example, first is fibrinogen. First, fibrinogen. No? Second, thrombin. Second, thrombin. 12, Hagemann. Hagemann, which is first fibrinogen. I don't write here because I'm not. Fibrinogen. Second, thrombin. Thrombin. Second factor. Second. 12, Hagemann factor, 12, 4, calcium factor, 4, calcium ions. Calcium ions, very important to have calcium around cells, around platelets to provide clotting. And 13, fibrin stabilizing. Fibrin stabilizing factor. It's plasma. And the next component, blood vessel wall. Blood vessel wall. Wall. Endothelium and subendothelial layer. Endothelium, and subendothelial layer. Blood vessel wall, very important. Endothelium. Endothelium releases substances again. Active substances. And endothelial layer contains collagen, and tissue factor. These are main components of hemostasis. The processes. Chain of events. Events. First stage, vascular platelet hemostasis. What happens immediately during blood vessel damage? Blood vessel damage, injury. Blood vessel injury. Injury site, yeah. Injury site presents some factors, tissue factor, tensions, and at first, fastest, vascular spasm, vasoconstriction occurs. First, vascular spasm, vasoconstriction. Why? It's caused at first reflex and stimulation of pain receptors, nociceptors, reflex, neural mechanism, and second mechanism, humoral, due to release from endothelin substance producing rapid, fast vasoconstriction. The primary vascular spasm, suddenly. Next responses. Responses occur together. It includes adhesion, platelet adhesion, aggregation, together, aggregation, and activation. Wait, processes. Platelets. platelets. What is adhesion? Adhesion is the sitting of platelets on surface of injured site. Why? Because значит, collagen molecules, yeah, collagen, attached to factor von Willebrand,
VW.
the factor F,
VW.
yes. Von Willebrand is a German person.
Yes.
Von Willebrand factor.
We study histology.
Very good.
Autonomy.
Yes.
Huh?
Very good.
Histology previous semester.
You have examined histology, it's good to recall. The factor von Willebrand binds to collagen and becomes active and binds to a receptor, platelet receptors. Platelet has special receptor for this factor, but this connection is possible only when factor von Willebrand binds to collagen, and it's called adhesion. Adhesion. 1, 2, 3. It's adhesion process. Together, at the same time, platelets stick each to other together. It's called aggregation. Aggregation. It happens due to fibrinogen, and other proteins, but fibrinogen is more important. Aggregation. Second process. And activation. Activation means change of shape. And platelets becomes like this. Increase surface, becomes more flexible, and release factors. Release factors, including factors enhancing increasing aggregation. What are the factors? Very important. ADP, and thromboxane 2. This factor increase aggregation. ADP and thromboxane 2. And injured endothelium also release these factors. It's positive feedback. Positive feedback. More activation, more ADP and thromboxane, more aggregation. But to prevent propagation of clot, thrombocyte plaque, platelet plaque, and thromb, to adjacent normal part, normal endothelium releases nitric oxide and prostacyclin, prostaglandin I2. These substances inhibit aggregation, negative feedback. At the injured site, there is positive feedback and increase aggregation due to ADP and thromboxane 2. Adjacent normal site release inhibitory factors, nitric oxide and prostaglandin I2, to prevent propagation of clot on the adjacent part, to limit propagation of clot and platelet. Well, as the first part, after activation and release of factors, what happens? At first, secondary spasm, secondary vasoconstriction, secondary spasm, due to release, for example, serotonin, and other factors of thrombocyte can produce a spasm. So it's, more spasm, less blood circulation here to prevent bleeding. Increase aggregation, enhance aggregation, more and more aggregation, and third, to start clotting, coagulation. Because platelet factors had not only clot formation, plaque formation function, they have regulatory function also. Well, this is enough about clotting. One, two, three. And result of increasing, enhancing aggregation will be log. Platelet plaque. But as I said before, platelet plaque is not stable. It can be removed by high blood flow. So it's necessary to have clotting, coagulation. Coagulation cascade. Coagulation cascade. It has extrinsic and intrinsic pathway. Extrinsic and intrinsic pathway. Coagulation factor, plasma factor, must connect with substrate. What is a substrate? Depending on way of coagulation, there are two ways: extrinsic and intrinsic pathways. Extrinsic, and extrinsic, and intrinsic. Extrinsic and intrinsic pathway. Extrinsic start on the base tissue factors. Together with plasma factors. Free factors includes phospholipids. Extrinsic pathway starts with activation sevens factor. At first, sevens must be activated by connection sevens factor with basement tissue factor together with phospholipids. 7 activates 10 factors, and this complex activates separately 5 factors. It becomes active. And composition of 10 factors active plus 5 active plus calcium ions, so 4th factor, and plus basement phospholipids. This complex, active complex, affecting thrombin, prothrombin, precursor, inactive prothrombin, and convert it to thrombin, active. Thrombin is key substance in coagulation. Thrombin, second factor. Second active thrombin. What about intrinsic pathway? It's longer. Intrinsic pathway start on the basement of phospholipids. Phospholipids from thrombocytes. Thrombocyte. It can start on the surface of platelets. Phospholipids, third factor, Arabic, because platelet.
Yes.
Start from Hagemann factor, 12 together with collagen and another substances. high molecule log name. You can see in my presentation what now to write. Big name. 12 factor, then 12 activates 11, then 11 activates NINS, and NINS activates 10. It uses cofactor 8. It helps for this. Okay. And 5. So finally, it has again 10 active factor, 5 active factor, calcium and phospholipid. This again is active complex. Again is active complex. Thrombin affect to fibrinogen, first factor, and convert it to into fibrin at first soluble. Then 13 factor converts soluble form of fibrin to insoluble fibrin. And fibrin
Thrombin
makes
affecting the fibrinogen and
fibrinogen is converted by
convert fibrin.
thrombin to fibrin
What?
to fibrin soluble molecules. And then fibrin is stabilized, which is soluble, stabilized and becomes insoluble by a certain fibrin stabilizing factor. Clotting coagulation has 3 stages. Formation of active complex, first stage. Second, formation of thrombin. And third, formation of fibrin. Each stage is controlled by some clotting and anti-clotting factor. It's very important to understand that thrombin is key substance in this response, and thrombin has a lot of regulatory function. Thrombin enhances activity of 5 factor, 10 factor, 9 NINS factor, 11 factor. The thrombin accelerates clotting, and at the same time, thrombin activates anti-clotting mechanism also, but I don't have time to explain it
lastly,
now. It's also, but mostly it's a system protein C system. Do you have questions? I said this topic is big, but
It's
I explained-
complicated. It's difficult topic.
No, not difficult. It has a lot of details.
Yes.
Just memorize, but logic not difficult. Actually, hemostasis is very difficult system in our body. It's very important to understand how does it work, because your patient can have problems during your medication, and maybe somebody from your family has problem. How to deal with anticoagulant drug taken. This drug, it's necessary to be very careful with drug affecting on the hemostatic mechanism. Because if you take drug decreasing hemostasis, with time your blood,
aspirin,
no, like aspirin. No, aspirin is harmful for our stomach anyway. But with time, blood change activity of hemostatic mechanism. It may be strength, maybe more strength. It depends on patient. For example, after surgery, if patient taken antihemostatic anticoagulant before, it's necessary to have pause, delay,
3 days.
before again return to taking. Because if immediately after surgery patient will take this anticoagulant, it may have
Hemorrhagic.
internal bleeding. It's a very, well, see you 32 group tomorrow. Blood will be not soon. Not soon. I think you forget my explanation, but you have